What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovy, and in this series, we're going to be building your game. So, just as a reminder, please leave all your suggestions for game ideas down in the comments below. I'll make sure to get to them very soon. So, last time we had gotten the bullets to shoot and follow where the spaceship goes. Got buggy over here, and we can scroll around on the screen, flip through, shoot bullets. It's all looking really nice, except we've got an issue here. These things down here are going to be your friends. They will tell you about what your game is really doing, because it's nice to have something on the screen, but when you're destroying your playdate, you better know about it. So just as a quick reminder, we've got the console here, which basically handles print statements, similar to the debug console here in VS Code. We've got the sampler. The sampler, what it does is that you can hit sample, and when you do stuff in the game, it will monitor which functions are running and taking up as a percentage of CPU. So here I'm firing a bunch of bullets, and you can... Okay. Too many bullets, apparently. The last one that we're going to look at real quick is memory. This is basically going to be a static list. So here you can see bullet as a class here. This one is probably harder to really visualize what's happening. And I don't know if it's this, but it also freezes my game apparently. So we're going to go up here in window and we're going to open up malloc log. Malloc is basically the memory allocation. It's a C function, and Lua runs in C, so Lua calls this when it needs to allocate stuff and deallocate stuff. So we're going to open up the map view because it's more visual, and you can see that we're looking at this like cyan colored thing, which basically means active memory in the heap. What's called the heap is just the memory store. You've got these pink lines, I should say, magenta, and basically when you shoot a bullet, you're creating a new class, a new instance of that class, and you can see that it's moving those lines around. So basically, Lua's taking care of moving around memory so that your new stuff has space to live, and it's not getting assigned randomly, it's getting assigned like kind of in let's say the first used chunk of memory. So what you'll notice that if we just keep shooting, let's say that we're playing the game, we're flying around, we're shooting bullets, you'll notice that we're just adding memory onto the end there, and it's not really going away. We're just continuously adding pieces of memory. And maybe it's related, maybe it's not, but my frames also have dropped, apparently, quite significantly. But that might just be the malloc log doing its thing. So the point here is that if you play for a while, we're going to consume more and more memory, which at the end of the day is called a memory leak, because it literally means that we're taking up memory and not cleaning it up, and means that, you know, after, let's say you play the game for 30 minutes, you've shot so many bullets that your game is out of memory, and then your game crashes. So something that a lot of game developers struggle with later down the line because they don't do things right. Personal experience. So how do we clean this up? First of all, let me show you real quick. Go back to the sampler, hit sample, and now you can see that this move by and this bullet.lua together take up about 60% of CPU. Potentially also including this update. So what I'll do is I'll turn off invert stack. I'll open up, sorry, let's stop it. Open up main.lua, open up update. You can see that bullet.lua, so bullet update, is taking up 60% of CPU, which is crazy. It's taking up 60% of CPU. So let's fix that. First thing we're gonna do, the bullets don't remove themselves from the game. So that's gonna be our first problem to fix. Pretty straightforward. We're gonna go into the bullet class, and when the bullet gets spawned, we're gonna add the line to the end of that function. We're gonna say self dot destroy timer equals playdate dot timer dot new and open brackets, and hold on one second. I'm going to explain what we're doing here. The destroy timer is going to basically get set when the bullet is created, and then after a certain amount of time, it's going to tell the bullet, hey, you don't need to exist anymore. So the bullet's going to destroy itself. So we're going to pass the first argument 1000, which is 1 second. And then we're going to pass a callback, and this callback is going to be a function that exists on the bullet. So we're going to do self.destroy. And then we need to pass a third argument, which is going to be the bullet itself. So we're going to do self. Reason we need to pass this is because these colon functions here have an implicit first argument, which is the instance itself. So that's the self. So it's almost like if you had self right here, and in fact, if we change this to a dot, bullet.spawn, and we pass self, it'll work. Nothing has changed here. So keep that in mind. We're going to create a function above spawn. We're going to do function bullet colon destroy open close brackets, and then end. And we're very simply here going to do self colon remove. So this is the graphics, the sprite, like the PlayDate sprite function to remove from the scene, which will stop the update calls. So probably save that CPU time that we were talking about. And that's pretty much it. That's your destroy timer. So we're ready now to look at this memory allocation problem, because this, we haven't solved the problem that every time you shoot a bullet, you create a new bullet. And so you're going to be creating classes every time you shoot, and it's just going to continue like that all the way through the game. So underneath this local constant local image bullet, we're going to create another section, which is going to be called local variables. And we're going to create a list. So it's going to be called sprite list bullet. And it's going to be equals to, actually nothing at all. It's going to be local sprite list bullet, and we're going to leave it like that. Then above, between the class definition, so class bullet, we're going to, and the init call, we're going to make a static function. So it's going to be called bullet dot, not colon, bullet dot create sprite list, open close brackets. So what we're going to do here, so this is going to be a static function that we can call from main.lua. What we're going to do here is that we're going to create a list. So we're going to use the same sprite list bullet variable, and we're going to do equals table.create, and then here we're going to pass in 10, 0. So if you guys don't know what this table.create does, it's actually created by Panic table edition. So they expanded on the table library of Lua. And tables, really quick explanation. They have two parts. They have an array part, which goes 1, 2, 3, 4, 5, 6, 7, etc. And then they have a hash count, and the hash count is also called a dictionary. So that's going to be more like if you do table with a key called Franchovy, and you put a value there, when you say, oh, my table Franchovy, you get the key. So it's not going to be a number per se. It's going to be more just random strings. It can also be numbers if they're really big, or if they're negative, or anything like that. So Lua is really, really flexible, because that's basically the only data structure that exists. So again, here we're creating an array style table called sprite list bullet, and we're going to do a for loop, a numeric for. We're going to do I equals 1, comma, 10. So we're talking about the same 10 here. Do, and then we're going to do table.insert sprite list bullet, and then here we're going to create a new bullet. So we're going to do bullet, capital B, open close parentheses. So now we're creating new bullets, but we're going to put them in this list and we're going to reuse them. So this 10 number, we're going to extract it out. We're going to go to the local constants underneath this image bullet. We're going to say sprite list bullet count equals 10, and we can add a const there. So sprite list bullet count, and we're going to use it on the table.create, and we're going to use it inside the for. So replace all those 10s with sprite list bullet count. So what this is, and by the way, this I, we're not using it, so let's replace it with an underscore. So this function here creates a list, fills them up with bullets. Simple enough. Now what we need to do is we actually need to use the bullets from the list when you want to spawn new bullets. So instead of calling init and then spawn, so if we go back to the player class, you're going to see that we're calling init, so bullet, and then we're calling spawn. So we're going to turn both of those into a single function. We're going to do function bullet dot spawn. So we're going over the same thing, the same spawn function that we had before. We're modifying it. So we're changing the colon to a dot, and then you've got all these parameters, which we can leave there. And so before we're going to be able to call a self, we actually, I'm adding a comment now, retrieve a bullet from the list. Okay. And so here we're going to say local bullet equals table.remove sprite list bullet. Okay, awesome. And then the next section, we're going to say add bullet to the scene. And so instead of saying self.add and everything like that, we're going to replace all these instances of self with bullet. And same with the destroy timer. Bullet.destroy timer equals blah, 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 blah. And then the last self needs to be bullet. And same with the self.destroy, needs to be bullet.destroy. So we're referring always to the object that we just retrieved rather than this notion of self, because we're not using instance function here. We're doing a static function. So static plays directly on the object that's created here. Meanwhile, anytime you call init, that creates an instance. Again, you guys will see much more of that in the future, so don't worry if it's not making sense right now. Okay, so last thing, when we've created the spawn function, but we also need to update the destroy function. So we're going to do the reverse way. We're going to add a comment to destroy. We're going to say remove the bullet from the scene. And so that's just going to be self colon remove. By the way, here we can use self because we're using a colon function. So it's passing itself and we're all good. And the second comment underneath remove is going to be add the bullet back to the list. So here we're going to say sprite list bullet. Sorry, no, restart. Table.insert, open brackets, sprite list bullet, and then self. So comma self. So now we're putting it back into the list when it gets destroyed. So here we have local bullet equals capital B bullet, open close brackets. So that's the init function. We're going to change that so that it's bullet dot spawn. And so spawn takes in those arguments, and luckily enough, we have them right in the line below. So we're going to take the self.x, self.y, vel x, and vel y. We're going to put them in there. We're going to remove that second line. And honestly, this bullet, we're not really doing anything with it. So we can just put an underscore there. And again, let's run, see if this works. Fly around, press B. Right, we haven't created the sprite list. So let's go to main.lua. And I'm going to add some comments here because it's a bit messy. So I'm going to go ahead and do that. I'm going to add first one underneath import menu, underneath all the import statements, basically. I'm going to say playdate libraries. Then I'm going to say underneath those two, I'm going to say not local constants, instantiate classes. I'm just going to say classes. Then we have init function. Then we have update function. Sorry, no. Yeah, okay. And at the very end, above the init, we're going to do game start. We're going to add one section underneath instantiate classes. We're going to do comment create sprite lists. In case we have more than one, we're going to do the same thing here. So we're going to do local, no, not local, bullet with a capital B dot create sprite list, open and close brackets. So that's going to create the list that we're going to use. It's the function that we wrote. Let's roll. And shoot a bullet. Whoa, guys, it's incredible. Nothing's changed. Whoa. All right, except something has changed. If you open up the malloc log, turn on auto refresh, and hit play. Okay, you're gonna see that basically even if we fire a bunch of bullets, oh, by the way, the bullets are not going very far. We probably need to extend that timer. It's not changing how much memory is that being allocated. So that means that we have a very constant amount of memory being used. It's not going to use more than that, which is really amazing. It's really, really awesome. And just for the full picture, this sprite list is keeping the sprites in there when they're not being used. And then when they're being used, they are taken out of the sprite list. So actually, any bullet that's on the scene is also not in the list, which is a useful property that we can have both on bullets and on the sprite list. If we go now to the sampler and we hit sample again, so remember we were at like 50 to 60% of CPU on the bullet.update. Let's keep going and let's see where it's at now. So still firing, still firing. Okay, and we're gonna hit stop. And we're gonna go into this function main.lua, update, bullet, 0.7%, guys. Mamma mia, that's an improvement right there. Just before we wrap up this episode, I wanted to go and do a little bit of cleanup. Back to the PDX info, I realized that the game is still called Tutorial 4, so if you haven't changed that, of course, change it to whatever you want. I'm gonna rename it to Spaceship until we have somebody suggest a better name, and at this point, I'm ready to accept whatever name comes, so please, guys, I'll do the pitch in a second, but leave your ideas in the bottom. Again, I'm going to change the bundle ID so it matches that. And we should be good. Delete this awful PDX that was there before. So we're all good. Guys, remember, this is a series all about you and what you want in the game. And I'm going to push on you guys a little bit. I want you guys to leave your ideas down below, your creative ideas. What should we be shooting at? Like, let's talk about aliens, military planes, balloons, UFOs, planets, you know, whatever other ships, why not? Again, another idea was to add different types of bullets. So rather than just having these little pebbles that are being shot, I wanted to have a big laser beam that would go like that straight across the screen. And that beam itself could have a kind of animation where it turns, and it could be much slower than the actual spaceship's particles, which is moving quite fast. What I'm thinking is that that's a bar at the top that gets filled up as you play the game, and then you get to use that whenever you want a stronger attack. I really appreciate you, all of you that are commenting. Really makes a big help, and you know, keeps this series going. So tune into the next one, and I will see you in the next one. Bye.